Hello viewers, in today's video we are going to look at electronic configuration and profile diagrams. So we're going to look at this is actually A-level chemistry for those who are in first year. Okay, so this question that came in one of the past papers. So the question says okay, so our focus here is on question B. This is question 3. Now we're looking at question B and C because these are coming from electronic configuration and profile diagrams. Okay, so the question says, that is B, write the orbital electronic configuration for nitrogen 2 max and oxygen 2 max. Okay, so how do we solve questions of this nature? Simple. First of all, you need to know the atomic number, because the atomic number is what tells us, okay, is what we use actually in coming up with the configuration. Okay, so the configuration for nitrogen is actually 1s2, 2s2, and 2p3. Okay, now this is condensed. Now what they want is the orbital, not condensed. So how do we write the orbital diagram? It's very simple. So we're going to say this is 1s and this is 2s, and the p orbital has got 3 sub orbitals, which we call them as degenerate orbitals. So we're going to draw, okay, 3 degenerate orbitals. This is 2p. If you want, you can divide this as 2p, okay, 2p x, then 2p y, then 2p z. But if you want, you can just say 2p, okay, 2p, then that's okay. Okay, so in the first shell here we have two electrons, one pointing up, the other one pointing down. In the next orbital we've got 2 also, so one up, one down. In the next shell, sorry, in the next orbital, which is the p orbital, we've got 3 electrons. So how is the distribution of electrons done in these degenerate orbitals? We follow Han's rule. Han's rule is what applies here. So Han's rule says when you're distributing electrons in the degenerate orbitals, each degenerate orbital should be singly occupied before doubling up. So we're going to put 1 electron in each of the orbitals like that. So once you put 3 like this, meaning that it's done. So this is the orbital. This is the orbital. Okay, this is the orbital electronic configuration or diagram. So you do the same also to oxygen. You do the same to the oxygen atom. So oxygen has 8. So you begin with 1s2, 2s2, 2p4. So you do the same. This is 1s, this is 2s. Then the p orbital should have 3, remember. So 2px, 2py, and 2pz. So there are 4 electrons. So each should receive 1. Each degenerate orbital should receive 1. So the remainder there will be 1. So which is going to be here. Of course, here is 1, 1, 1, 1, 2, 2, 2 in each, like that. So this is the orbital notation or electronic configuration for oxygen. And this is how you solve questions of this nature. So by writing like this, then you should have scooped the 4 marks indicated here. Okay, so C also says, using the same elements, write down the energy profile diagram for nitrogen as well as oxygen. So you do the same. Now when drawing the energy profile diagram for any given element, we begin by writing down the atomic number like that, so that you're guided, and then you draw an arrow pointing upwards, then you indicate energy like this, and then down here, which is the ground state, we are going to have remember, we are also following the same electronic configuration. So we have 1s, you write like this. This is your orbit of 1s, and then up there you put 2s. Then up also here you put 2p. So 2p has got how many suborbitals? 3 of them. So 1, 2, 3. So 1, we put the electrons, which we have here. You also put here 1 up and 1 down, and then here we've got 3. So put 1, 1, 1. So this is the profile energy diagram for nitrogen. So by doing this, you earn this number of marks indicated here, which is 2 marks. Then oxygen also, you do the same. So for oxygen, you also do the same. This is the ground state. This is the energy, meaning as you're going up, as you're moving from 1s orbital to 2s orbital, there's an increase in energy. So 1s, remember oxygen is 8. So 1s, 2s, 2p. Now p has got 3 suborbitals. So we have 1. Here, if you check properly here, we have got 2 electrons in the 1s orbital. So one pointing up, the other one pointing down. You come to 2s. The 2s has got 2 electrons as well. So one pointing up, the other one pointing down. Then you come to 2p. If you want, you can say 2px, 2py, 2px, 2py, and 2pz if you want. It's okay. So we're going to say, how many electrons are in the 2p orbital? We have got 4 of them. So we're going to distribute 1, 1 in each. Then the remainder is 1. So you put it here, and this is the energy profile. It's the energy profile diagram of oxygen. So this is how you solve questions of this nature. I hope this helps. Thank you so much. Subscribe to our YouTube channel for more amazing tutorials that will help you succeed in your various courses. Thank you so much. Once again, Emmanuel is your mentor. Thank you.